Hey everyone, welcome back to the channel. So in today's video, we are going to discuss about four more concepts. So in the previous section and the previous video, we discussed about chat models, messages, chat history, tools, tool calling, and also memories. So now we'll discuss about four more concepts: structured output, multimodality, runnable interface, and streaming. That too with code examples. Okay. So first, let's start with the structured output concept first. So as the name suggests, structured output means structuring the output of the LLM or defining the structure in which it should generate an output for us. So by default, what an LLM does, given a input query or input string, it just generates the output in a text format or in a paragraph format, right? So what we can do is, using this structured output concept, we can actually direct the LLM to generate the output in a defined structure or defined schema. Okay, so you can define the schema like this using a JSON or using a Pydantic class like this. Okay, and it will give you the answer in a desired section in the desired manner. So let's not go through this documentation. Let's directly jump to the code first. Okay, so if we go here, let me first just import my key. I've imported the key, and here we are using GPT-4 mini OpenAI model. All right, I have imported the model also. Now if you see, if we don't provide any structured output schema to the model will generate a plain output in a string format. For example, if I just directly invoke the model with the query, okay, this is the model and this is where I am invoking it. If I just run this, it will take some time to generate output. If you see, it has generated a entire paragraph for us, okay, in the content section. If you see, all right, but what I want is, I want the LLM to generate an output in my own defined schema, because there will be a lot of cases where you want the output to be in a structured format, in a structured manner, in a key value pair manner, so that you can reuse that output in your further layer of your application, right? Just like you exchange JSON in your APIs, it's similar to that. So what we'll do, we'll first define a schema. So here I have defined a Pydantic class, okay? Pydantic class I have defined, and I have my class is two keys. One is the answer and the follow-up question. Answer is nothing but the answer to the user's question, and follow-up question is a follow-up question that the user could ask. So LLM will think on its own and generate a question for us and give us in the output. Now what I am doing, I am using the with structured output method of this model. Okay, then I am passing the schema or the response formatter. This Pydantic class I am passing to it. So now my model, LLM model, is aware about the desired schema that I want it to generate the output. Okay, now if we run this, now you'll see, now instead of model, we'll use model with structure. If I run this, you'll see one thing. Let it run. It is running still. Now if you see, the output has only two things. Okay, one is the answer section. Okay, this is the answer, and the second one is the follow-up question. Okay, what are some of the Virat Kohli's record in cricket? So this is how we can structure the output and format the output according to our own will and our own defined schema. So LLM will do that for us. Okay, so that was about structured output, nothing else. Let's not drag it further. Okay, it's a very simple concept. You can go through the documentation for different type of other way to define the schema, just like using a JSON. Okay, all those things you can explore. So it's pretty simple. Okay, now let's just quickly jump to the next section of multimodality. Now multimodality means multiple types of modes of data. Okay, different types of data, modes or types of data. That means audio, image, text. Currently we have seen till now ki LLM, till now we have used LLMs with text based data, right, textual data. But LLMs are, have become more powerful right now. They can deal with audio data, image data, PDFs also different kinds of data it can support. So it's known as multimodality. However, not all the chat models that are available, they support multimodality. Okay, for example, OpenAI supports multimodality. Gemini has its model, it supports multimodality. So you can see here, you can find which model supports multimodality. Okay, for example, Mistral AI, Fireworks, they do not support multimodality as of now. uh, so so now let's just jump to the code. Okay, and we'll see multimodality in action. What we'll do, we are using chat OpenAI. Okay, because OpenAI supports multimodality. If you can see here, you'll see that OpenAI is the OpenAI is here, and it supports multimodal exchange of the inputs and outputs. So here what we have done, we have used a model of GPT-4 audio preview. Okay, so this model of OpenAI has the capability to deal with input data which is of type audio. Okay, so not just text type, it can support, it can work with audio data also. So for this, what I have done, I have downloaded one file of called Harvard.wav. Okay, this is the audio file that I have downloaded. If you see here, if I just play it for you,
The stale smell of old beer lingers. It takes heat to bring out the odor. A cold dip restores health and zest. A salt pickle tastes fine with ham. Tacos al pastor are my favorite. A zestful food is the hot cross bun.
so this is the audio file that I have imported, and most importantly, what I have done, I have converted the audio into a base64 encoded format. Okay, that's the important thing. See, LLM somehow, in order to make the LLM understand about the audio file, it has to be converted into some format, right? I mean, it cannot just directly process the live audio signal. It has to be converted into, let's say, base64 in this case. And if you are dealing with images has to be maybe converted into some base64 format, or images can be utilized in, we can generate multiple different kind of captions and description for a image, okay, using some OpenCV model or image processing models, right? And then utilize those description and feed it to the LLM to take further actions and do further furnishing on the input. So this is what we are doing here. In this case, what we are doing is simply converting the WAV file, the audio file, to a base64 encoded format. Now this base64 encoded format will be passing to the model. Okay, here I am invoking the model as the audio data. Okay, if you see, I am passing the base64 encoded format as the audio data here. Okay, so there are two sections, obviously, two types of message which you are sending. First one is to transcribe the following, which is a text data, the instruction that I am giving. The second one is the input audio, because this is the format which this GPT-4 audio preview model understands. Type is input audio, and input audio in the data I have given the base64 encoded format. Okay, and the original format of the file also we have given. Where now if I print this, okay, it will take some time to process, and let's just play this audio in parallel. Let it generate the response first. It will take some time because it is, yeah, it has generated the output. That means it was correctly able to you know um, create a transcription for the given input audio file. Okay, now let's just run this and see.
The stale smell of old beer lingers. It takes heat to bring out the odor. A cold dip restores health and zest. A salt pickle tastes fine with ham. Tacos al pastor are my favorite. A zestful food is the hot cross bun.
So it was successful able to create a transcript for the audio file. So this is just one example of how you can use input data as audio files. Okay, so you can uh, play around with other models and other type of data, other modes of data, PDF, then you have images, right? So you can work with that and it will be fun for you. Okay, so this is how we deal with the multimodal data or multimodality. Okay, so that was about multimodality, nothing else actually. So let's just jump to the next concept. Okay, now we'll discuss about the runnable interface. Okay, so this is a kind of theoretical. See, runnable interfaces are the basic core. It is the foundation block of all different type of components in LangChain. For example, we have chat models, right? Language models. We have output parsers. We can define the parsers. Maybe we'll discuss about parsers when we'll be discussing about chains, right? What is actual chain in the LangChain? I'll create a separate video about that. So output parsers are nothing but the way to format the output. Okay. Then we have retrievers. Retrievers are again related to agents. It is used to retrieve relevant data from a vector database. Again, you can check out my video on LLM agents. You can click on the eye icon above. You'll get to know about this. Okay. So runnable interface are the foundation block or foundation class of all these type of components. Okay. If you see, it can have multiple common methods. Okay, for example, our LLM models have methods like invoke, batch, stream, which you already saw. when we were discussing about chat models, right? So these are nothing but these have been inherited from the runnable class, okay, runnable interface. So there are some other methods which we already saw about streaming and streaming, right? We can stream the output from this runnable configs, okay, or runnable interface. Streaming means as the output is generated, we'll go on we'll go on receiving the output from the LLM model instead of getting the entire response at once. We're going to discuss our stream next, so don't worry. I'll show you a live code example also. So if you see, there are different type of components which are built upon this runnable interface. Okay, the prompts which we design. The prompt is also a runnable config. You can invoke a prompt actually. Then we have a chat model. Is nothing but the chat model class we already saw. Then LLMs. Okay, so LLM models, the actual models that you use. Then output parser, which we'll discuss in a while. I mean, and then we have the retriever. Retriever is used to, as I told, to fetch relevant data from vector database. So then the tools. Tool calls which we saw in our previous section, tools are also a part of the runnable interface. Okay, they inherit a few methods and properties from the runnable interface. So tools can also have this kind of invoke, bash, stream, all the kind of methods they can have because it belongs to the runnable interface. Okay, so then that there is runnable config which we already discussed when we were discussing about tools. Okay, so in runnable config is a extra set of um, second argument, okay, that you can pass along with the different methods that it supports. As we saw, runnable interface supports invoke, bash, stream, and stream events methods. So inside these methods is a second argument we can pass this runnable config, okay, and runnable config can have one or more of these keys: run name, run id, tags, metadata. Okay, if you see here, this is one sample that they have given. Okay, some runnable, let's say it's a chat model, it's a prompt, or it's a, let's say, what is it's a, let's say, tool. Okay, so these are some of the components with a runnable interface implemented. So we can invoke them with some input, that defined input, okay, which they support as the first argument. And in the second argument, we can actually pass a config like this. And here we can pass any kind of metadata configuration that we want as we want. Okay, so but the parent keys of this runnable config has to be one or more of this. Okay, so that's how the runnable configs works. Yeah, this is what a chain looks like. Okay, this is just a gist I'm giving you about a chain. If you see, chains are components of a chain are separated by a pipe symbol. Okay, so this is just show the flow of, this shows the flow of execution of input. Okay, input will now first come to the prompt, then prompt output will be passed to chat model. Okay, then chat model's output will be passed to the output person, then the final output will be generated. So it's a complete chain. Okay, chain of sequence of execution of the LangChain. Okay, again, don't worry, I'll create a separate video as I told. So this was about runnables. So next we'll discuss about streaming. Okay, the name suggests itself. Streaming is, streaming the output. I mean, as the output is generated, you send the output in a chunk by chunk manner instead of just waiting for the entire LLM to process your query, then generating a big chunk of data and big chunk of output and throw it on your face. Not like that, because streaming can be, quite useful to enhance the user experience. Okay, so we can actually stream the output in a synchronous manner and asynchronous manner also. For asynchronous streaming, we use stream, where you don't want the output to be generated in a sequential, in a chunk, word by word manner. You want the output to be generated in a parallel manner. You can use stream, but for synchronous streaming, you can use stream. Okay. Now, without just uh, wasting much time, let's just see the code of streaming. Okay. Now I'll show you. Yeah, this is where I've created. See, this is a prompt template that I've created. This is my prompt. Then there is output parser. Then I've created simple chain. Okay, we have a prompt. Okay, this is my prompt. Then we have the model, which we have already, initialized here. Okay, then we have the output parser. Then what I am doing for event in chain.stream. If you see, I am just using a stream. I'm just calling the stream method of this chain, and then passing the topic is Indian cricket. Okay, so that it will uh, invoke the prompt, because the first layer is prompted. So prompt will be invoked with this topic Indian cricket, and the final prompt will be tell me a joke about Indian cricket. Now we'll see how the stream works. Okay, if I just run this, you'll see that the outputs are generated. Yeah, now it looked like it generated output at once because it was too fast for our eyes to catch. So what I'll do, I'll just do a time dot sleep of 1 second once. Okay, then we'll see. Okay, now if you see, it will just generate the output in a word by word manner. Okay, what did it will generate a stream of response like this. So ChatGPT, that's how it shows you the animated response, right? Word by word it comes up, right? So this is how it is generating the output in a stream manner. So I hope you understood the four concepts which we discussed just now. So we discussed about structured output, multimodality, runnable interface, and streaming. Okay. So if you have any doubts about whatever discussed in this video, put them in the comment section. Let's discuss and get your doubts cleared. Okay. So if you like this video, hit a thumbs up to my video and subscribe to my channel. We are targeting to reach 2200 subscribers by the end of this month. So keep supporting. So you can check out my playlist on LangChain crash course. So this is our fourth video in this playlist. So you can check out the other three videos. You'll definitely like them. So thank you for watching this video and I'll see you in the next one. Thank you.